So we said we can look at the spectrum of stars and learn a lot about them. So what we're going to do here is we're going to look a little bit more at the spectra of stars. Um, Angelo Secchi is often regarded as the father of stellar spectroscopy. And he did this work in the 1800s using a little prism held up to the eyepiece, looked at the spectrum of stars, and he realized that, hey, some stars have some certain spectral lines, other stars have other spectral lines, so he grouped them into 5 basic groups based on what he thought that he saw. And so with that, he got an idea of there being different kinds of stars that are out there. So that was fine. But it was just visual. And it was just what he saw. And he did hundreds of stars, but he could only do what he could see. Henry Draper comes along, and Henry Draper actually has the ability to photograph the stars. And so Draper has a camera, and the back end of the camera was a glass plate. And on his glass plate, then what he had was some chemicals that when the light hit it, it caused a chemical reaction. This is like precursors to film. And so what happened was that he would point this in the sky, take like a 10-hour exposure, and get the spectrum of a star. And he could do a star at a time. And so he photographed the spectrum of a number of stars. And the advantage is you could then take the spectrum to the lab afterwards, use calipers to measure it, use magnifying glasses to measure it, and make all kind of detailed measurements, not just looking in there and sketching what you see. So this is an objective sort of look at it. So that was the idea. And so then what he did was he died eventually, and his wife donated a bunch of money to Harvard Observatory, where they hired immediately Ed Pickering. And Ed Pickering oversaw the new spectral classification. And so what he did was, he said, well, wait a minute, what we can do is put the prism in front of the eyepiece so that glass plate gets a whole bunch of spectra. And so then what you would have to do is just take this glass plate, develop it, take it to the observatory, and during the day analyze all this. It might take a couple of days to analyze all the spectra in great detail. And so we did this and got quite successful at it. The problem was he didn't have time to do all the analysis himself, and he was trying to get his graduate students to do it, and they weren't interested in doing this because it didn't directly benefit them. And he got so exasperated, and they said, well, it's hard. We don't want to do it. It's hard. And he said, look, this is not that hard. I can hire my housekeeper to do it. So that's exactly what he did. He hired his housekeeper, Williamina Fleming. Now, it's not entirely fair because Fleming was an amateur astronomer, and she was just dying to be able to do real science. And back in those days, women weren't generally allowed to work, to do real science type stuff. And so there was a lot of discrimination against them. And so he said, well, go ahead and let you do this. She did a great job. What she did was she started looking at what Secchi had done and expanded it to other things, starting letter A, B, C, D, E, etc., all the way down to M, N, and O. And so she grouped all the stars by how much hydrogen was in the spectrum. A had the most hydrogen, then B, all the way down to O, which had the least. And so that was her idea. Now, she was so great at that. By the way, they published her work as the Harvard Revised Photometry. Now, in those days, again, discrimination against women in science, astronomy is a little bit more forward, and they hired, and so that was okay, but the publisher was real reluctant to publish it under her name. So it was actually published under Edward Pickering's name, with Williamina Fleming listed as co-author. So, but she was so good, she was so good at this that he decided to hire a bunch of other women. And they jumped at the chance to do real science. Now Pickering got in trouble with the administration there at Harvard at the time because Harvard was all men. They didn't allow women to take classes there. They didn't have any women faculty. They did not have any women working there, even other than a few that worked serving food in the dining halls. And so his idea of hiring women to do real science in the lab here was like completely revolutionary. But they were eager to work and do real good science. And in fact, turns out in this photograph that was taken early part of the 20th century are some of the most influential women, or not just women, but some of the most influential astronomers in the 20th century. They didn't know it at the time when they first got hired, but they had done fantastic work here eventually that made them all premier astronomers. One of them being Annie Cannon. Annie Jump Cannon, one of the women that he hired here, and she took Williamina Fleming's list of stars and arranged them from O, B, A, F, G, K, M. Not just A, B, C, D, but arranged them in order of temperature, from hot to cool. Okay. So the O stars, it turns out that when you looked at it, A, B, C, D, and so forth, it turns out there were only about 7 different spectral types that stars tended to group in, so she grouped them all into that group. And so O's are the hottest, B's the next hottest, and the K's and the M's are the coolest. On this system, the sun is a G-type star. Okay. And so O's are blue hot. Remember, the color of the stars related to the temperature, so the O's are blue hot. B's are kind of bluish. A is white hot. F's and G's are kind of yellow hot. K's are orange hot, and M's are red hot. And so she then went one step further and said, well, we can break all of these into 10 subgroups. So we have B is not just B, it's B0, B1, B2, and so forth, all the way down to B9, and then it starts A0, A1, and so forth. So an A0 is right next to a B9, and so a B0 is right next to an O9. So a B1 is closer to an O9 than it is to a B9. Okay. So we classify the spectra from O to M. The spectral lines that you see dominate how you classify them. So the A-type stars, you look for the spectral lines of hydrogen. You see a bunch of hydrogen in B-type stars. You see a lot less of it in O-type stars. G stars, there's some other spectral lines like calcium spectral lines, ionized calcium, you get neutral calcium for K's and M's. And so there's different spectral lines you use to try to figure out which star is which. Astronomers, have had to remember the order O, B, A, F, G, K, M for a long time, and so the way they do that is they create a little mnemonic. So for astronomy books for years and years and years said, "Oh, be a fine girl, kiss me." Okay, so "Oh, be a fine girl, kiss me," or "Oh, be a fine guy, kiss me," and so that gives you the orders right there. So remember, I said we'd get back to this table of data. Well, we're about to talk about that. So the next video, we'll talk about this table of data and how you figure out which star is which, temperature, and so forth from the spectral type.